for joining me. We have some problems to solve. Now, the first problem we have on the board is from this diagram. Now, the question says, given the diagram, calculate the refractive index of figure X. That is the first question. Second question, if the apparent depth of X is 46 centimeter. If the apparent depth of X is 46 cm, calculate the thickness of X. Okay, let's go. Solution. Now, from this diagram, I is not given. That is angle of incidence. Angle of incidence is not given. Remember, this is not angle of refraction. This is where angle of refraction is. Therefore, we can now say that, use our formula. Remember, angle of incidence is equal to 90 degrees minus the glancing angle. This is the glancing angle that is given here. Therefore, I is equal to 90 minus 30. Therefore, the angle of incidence is 60 degrees. Now, for angle of refraction, still the same thing we did here, we're going to do it here. R is equal to 90 minus 60 degrees, which will give us 30 degrees. So, angle of refraction is 30. We can now say refractive index is equal to sine I all over sine R, which will give us sine I is 60. Sine 60 over sine 30, which will give us sine 60 is 0.866 all over sine 30. Sine 30 is 0.500. Now, we will now take 0.866 divided by 0.55. We will now have that refractive index mu is equal to 1.57. 1.57 is our refractive index. So this is for question first one. Now for the second question, we want to find the thickness of X. So given that the apparent depth of X is equal to 46 cm. Now we want to find the thickness of X. Thickness of X is something as the real depth of X. So real depth of X is unknown. So remember that our refractive index is 1.57. Therefore, refractive index is real depth all over the apparent depth. Of course, the apparent depth here is unknown. So we have mu. Mu is 1.57 is equal to real depth, which is, you can have it as X all over the apparent depth. Apparent depth is 46. You can decide to convert to meters, or you can decide to work with this. If you work with this, that means you will return your answer in cm. So which will now give us X is 1.57 times 46. Therefore, X is equal to times 40 times 1.5 times 46. It will give us 72 centimeters. So the thickness of this block X is 72 cm, while the apparent depth is 46. So if you decide to, of course, you know what to do. If you want to move down to say a meter, it will now give us that is 0.72 meters, as the case would be. So, okay. So we will take the second question. So the second question says, a glass plate 0.9 cm thick. A glass plate 0.9 cm thick has a refractive index of 1.50. How long does it take for a pulse of light to pass through the plate? How long does it take for a pulse of light to pass through the plate? Given that the speed of light, c, is 3 times 10 raised to the power 8 meters per second. So we solve this problem. Okay, so we have, from the question, we have that the time is not given. How long does it take for that pulse of light to pass through? Now, there are the two media in question here is air and glass. Now, speed of light in air, velocity of light in air is 3 times 10 raised to the power 8 meters per second. Okay, so where the next thing given to us is the thickness of the glass. Thickness of the glass is the real depth, which is 0.9 centimeter. Okay, so the refractive index is also given to be 1.50. Now, what do we do? Since the two media in question here is glass and air, and the speed of light in glass is given, the first thing we do is to get the speed of light in glass. So we now have, recall that refractive index is velocity of light in air all over the velocity of light in glass. So we have 1.5 is equal to velocity of light in air, 3 times 10 raised to the power 8 all over velocity of light in glass. We can cross multiply at this point to make glass the subject. Velocity of light in glass will now give us 3 times 10 raised to the power 8 all over velocity of all over 1.5, which will give us, from here, this one can cancel here, 3 divided by 1.5 will give us 2. So 2 times 10 raised to the power 8 meters per second. So this is the speed of light in glass. Okay, so since we have the speed of light in glass, and we want to find the time taken for this light to pass through the glass plate, which will now give us. So we also say, recall also that velocity is given as displacement all over time. Okay, if you make t the subject, we now have distance or displacement all over velocity. Now this distance now is the thickness. So we have the distance is the thickness of the glass, or the length of the glass. So what we do is to convert this to meters, because speed of light is in meters per second. So because of this, we convert this to now give us, we'll convert this, we'll have 0.009 meters. So we substitute into this. If we substitute, we have the distance 0.009 all over the velocity, which is 2. Remember, the velocity we're using is the velocity of light in glass, because it is a glass medium, times 10 raised to the power 8. This over this, you can get the answer straight, or you move it back, let us simplify it small. So which is going to give us t is equal to 9 times 10, put this in standard form, it will give us minus 3 all over 2 times 10 raised to the power 8. 2 can divide from here to give us 4.5 times 10 raised to the power. You bring this one first, then this 10 raised to the power 8, bring it up. If it comes up, the sign will change to minus, so we have minus 8 here. So which will give us 4.5 times 10 raised to the power. Minus 3 minus 8 will give us minus 11 seconds. So this is the time it will take the pulse of light to enter the glass. Alright, so we have another one. We can solve this other one. This other one says the velocities of light in air and glass are, the velocities of light in air and glass are 3 times 10 raised to the power 8 meters per second and 1.8 times 10 raised to the power 8 meters per second. Now the question says, calculate the sine of the angle of incidence. Calculate the sine of the angle of incidence that will produce an angle of refraction of 30 degrees. Okay. Now we have from the question the sine. Remember the question says calculate the sine of angle of incidence and not the angle of incidence itself. So we're looking for sine I. So sine I is unknown. R is 30 degrees. Velocity of light in air 3 times 10 raised to the power 8 meters per second. Velocity of light in glass 1.8 times 10 raised to the power 8 meters per second. So think, okay, we have the refractive index is not given. So recall that we have the refractive index is, since we're looking for this, refractive index is equal to sine I all over sine R. The same refractive index is equal to velocity of light in air all over velocity of light in glass. So it's either we use these two to get refractive index and come back to substitute into this equation to get our sine I, or we ignore this one, equate these two. So if we equate these two, we have sine I over sine R is equal to VA all over VG. So let us substitute straight. So sine I all over sine R is a 30 equals velocity of light in air 3 times 10 raised to the power 8 all over velocity of light in glass 1.8 times 10 raised to the power 8. At this point, we can cross multiply to get our sine I. So we have 1.8 times 10 raised to the power 8 sine I is equal to 30, sine 30, please. Is equal to sine 30 times 3 times 10 raised to the power 8. So we now have sine I is equal to sine 30 times 3 times 10 raised to the power 8 all over 1.8 times 10 raised to the power 8. At this point, we have sine 30 is 0.5 times 3 times 10 raised to the power 8 all over 1.8 times 10 raised to the power 8. So which will give us remember this is just sine I. Sine I is equal to 0.5 times 3 will give us 2 times 10 raised to the power. It should give us 1.5 please. 1.5 times 10 raised to the power 8 all over 1.8 times 10 raised to the power 8. At this point, these two can go. If two of them goes out, we have 1.5 over 1.8. And 1.5 divided by 1.8, by calculation, we'll have 0.833. Therefore, we can say that sine I now will produce a refraction of 30 degrees is equal to 0.833. And this is our answer. Thank you very much. This is where we'll draw the lesson to an end. Please tell me how impactful this lesson is. Tell me down there in the comment section. Please do not forget to hit the like button, subscribe to this channel because that is what motivates me to continue to create more videos for you. Thank you.